So this is the part 2 of the linear inequality video. Remember that in the previous one, I didn't finish part C, D, and G and H. I'm really going in alphabetical order apparently. Another thing that in the previous video I did not do, just detail, but it's important to add it, is that I didn't write here my interval from -1 to 3/2. You do want to write that as your answer, your solution, and probably next time you want to box it, but details, I forgot about that. If you give me the graph, I'll be pretty happy already. So, but don't forget to write the interval. Nonetheless, let's proceed with this one, and this one will pretty much operate more or less like we would do any equation. So we would start by distributing this here. Please do not divide the -2. It's just going to make things ugly. Instead, just distribute it. Now, here you have a choice. You could subtract x on both sides. You end up with a negative coefficient. It's not the end of the world as we've seen, but you could just add 2x then on both sides, and then you avoid that negative coefficient because you end up with a +3 here rather than a -3 on the left-hand side. No big deal, but it makes your life easier, so why not? Now here I eliminated this 2x, so I kind of want to grab this -3, then add 3 to cancel it, so that I end up with all the numbers on one side, meaning my left-hand side, and all the x's on another side, I mean the right-hand side. So now you cancel a -2x with the 2x, you get -1 plus 3, it's just going to be +1, less than, now I get 3x, so x plus 2x, 3x, and then I have the -3 plus 3 that I did in such way to cancel the -3 there. So now I just have to divide by 3 on both sides, +3, so I don't have to reverse my inequality, so I get 1/3 is less than x, in which case I'm just going to write the interval here because we've done a lot of the graphs, but I'm just going to do the interval here. So I'm going to go to the right of 1/3, so I'm going to do 1/3 to +infinity. Right here, the one thing you want to notice is that this is going to be a strict inequality, so you want a parenthesis rather than a bracket. So this gives you your open parenthesis here. Okay, so that's the only thing to notice. Everything else in that problem is the same as we did before, maybe a little bit more algebra, but nothing too fancy. Right here we have a two-sided or compound inequality, they call that. You see, I forget names. So anyway, so what I'm gonna do is add 3 on each one of the parts of the inequality, and I get -1 plus 3 is going to be +2, less or equal to x minus 3 plus 3. Well, that's why we added 3 to cancel that guy. So I get x less than 4 plus 3 is 7. And now I'll draw this one because it has two inequalities. So we're going to do from +2, sorry, I was going to say -2, from +2 inclusive to 7. And here I'm going to then use a bracket and a parenthesis, and I'm going to grab my interval right there. And then what I would then do is write this in interval form, and I wrote the wrong one because I need a square bracket. So 2 to 7 open, and that's then my solution set right there. Okay, so for part G, or for G, we need to talk before we start working on this. Why? Well, because remember when we're solving equations where we had absolute value, we basically had to consider when the inside of the absolute value or the argument was the negative, and then whenever it was the positive. So we had that situation going on. So the same thing is true here, but we're saying that we're going to consider all numbers. Forget about this x plus 3 for 1 second. We're considering all numbers whose absolute value is less than 5. So for example, you want numbers like, say, 0. Yes, because 0, the absolute value of 0 is 0, which is less than 5. You want 1. Yes, because 1 is less than 5. Negative 1. Yes, because if you have negative 1, you take the absolute value is positive 1. Positive 1 is less than 5. You want negative 4, of course. So what I'm trying to tell you is that the interval you're interested in is this one right here. So your x plus 3 has to land, whatever value x is, x plus 3 has to land here to satisfy this inequality, right? Okay, with that said then, let's rewrite this inequality with absolute value as it should. So the way you rewrite this is going to become the values of x that make x plus 3 greater than negative 5, but less than 5. So that's how you rewrite that inequality. Again, just very similar to what we did with equations, right? We had plus minus, right? So same thing is going to happen here. So I'm going to subtract 3 on both sides. Well, both. How do you say both whenever it's 3? Throws? No, you don't say that. Anyways, so negative 5, negative 3 is going to be negative 8. X plus 3 minus 3, just x. And then less than 5 minus 3, 2. And that right there will give you your solution. So we are going to draw it. So from negative 8 to positive 2. And we do open parentheses because the inequality is straight. So right there, we have that, and we write our solution set as negative 8 to positive 2. And that's as simple as that, if you will. So basically, this inequality is just a special case of this one right here. So nothing new, nothing too exciting, but we need to address it. So same here. So from negative 1 less or equal than negative 2x plus 1 less or equal than 1. We're going to address it the same way we did before. We're going to eliminate this 1 by subtracting 1 at every part of the inequality. I said it right this time. So negative 1 minus 1, negative 2 is less or equal than negative 2x plus 1 minus 1, so it goes away. 1 minus 1, 0, so less or equal than 0. So now I divide by negative 2, but you got to be really careful because when you divide by negative 2, you're going to have negative 2 over negative 2 greater or equal. Remember, I'm dividing by a negative number, so got to be very careful. And then greater or equal than 0 divided by negative 2, which is 0 nonetheless. So we'll just write it. So we get 1 greater or equal to x greater or equal to 0. And at that point, then I just move to the side and I can draw my inequality 0 to 1. And this one will be closed brackets because I have the equal sign. So it's going to be an inclusive relation there. All right, so we have that. And we just write it in interval form, our solution set as 0 to 1 closed. And that's pretty much it. Let's see what else we have for today.